Find the coordinate vector for basis b defined by vectors b sub 1, b sub 2 using the inverse of the change of coordinates matrix. So let's begin by recalling that if we're given some basis b defined by the vectors b sub 1 through b sub n, then the coordinate vector is defined as the product of the inverse of the change of coordinates matrix p sub b multiplied by vector x. So let's first here identify what is our change of coordinates matrix. So we have our change of coordinate matrix p sub b is defined by the given vectors b sub 1, b sub 2. So we have a 2 by 2 matrix here, -2, -4, 2, -3. And so what we want to do is find the inverse of this matrix. So we can use that 2 by 2 definition to find the matrix here. So we can go ahead and we'll let this change of coordinates matrix be defined as A, B, C, D. And so we know by our 2 by 2 definition that the inverse of the change of coordinates matrix will be defined as 1 by the determinant of the change of coordinates matrix multiplied by the matrix D minus B minus C A. So the first thing we need to do is find our determinant. So we have the determinant of the change of coordinates matrix is equal to -2 multiplied by -3 minus a -4 multiplied by 2. So we have 6 plus 8. So our determinant is 14. Doesn't equal 0. So the inverse exists. We also know because our change of coordinates matrix is defined by the vectors that make up our bases, we know that it's automatically invertible because by definition the basis is linearly independent. So let's go ahead now, we'll find our inverse matrix. We have 1 by the determinant. So here, we can go right for it. We have 1 by the determinant, so this is 1 by 14 multiplied by the matrix -3 minus 2 +4 -2. And we can distribute our determinants, so we're left with -3/14. Then we have -1/7. Then we have 2/7. And then another -1/7. And so we're ready now to go ahead and take the product to find the coordinates, or to find the coordinate vector. So we have that the coordinates of vector x relative to the basis, again, is defined as the inverse of the change of coordinates matrix multiplied by vector x. And so we have that matrix that we just found. So let's do it like this. We're going to take this matrix and we're going to multiply this by that given vector x, which was defined by 4, 1. And we'll go right ahead and apply that row column rule. So we have the first row multiplied by that column vector 4, 1, which leaves us with -6/7 plus -1/7. And then the second row times the column vector, we end up with 8/7 plus another -1/7. And this leaves us with, so we're lucky here we have a common denominator. So in our first entry we have -7/7, and second entry is +7/7, which leaves us with our beautiful final answer of -1, 1. So these are the coordinates of vector x relative to our basis b.